Today we'll discuss ISI's B-Stat B-Math 2021 UGP paper, and the first question is, we are given a number which is 2 square, 3 cube, 5 to the power 5 and 7 to the power 7, and we have to find number of ways in which it can be expressed as product of two numbers A and B, where GCD of AB is 1, where A and B, they are both greater than 1 and A is less than B. Now since GCD of AB is 1 and we have to express this number as a product of two numbers A into B, so we have A and we have B. Now for this 2 square we have two choices. For this 3 square we have two choices. For this 5 to the power 5 we have two choices, and for 7 to the power 7 we have two choices. So we can express this n as a product of two numbers in 2 into 2 into 2 into 2, that is 16 ways. Now out of these 16 ways, there are two ways in which this A is 1 and B is n, and another way where A is n and B is 1. So we'll discard this possibility since A is greater than 1. So we are left with 14 such ways. Now out of 14 ways, there will be 7 cases where we have P in A and Q in B, and then there will be 7 cases where there will be Q in A and P in B. Now out of this P and Q, one of them is greater. So that means total number of ways in which A is less than B will be half of 14. That is simply 7 ways, and that's your option C. Now question number 2 is, we need to find sum of all the solutions of this equation. So what we'll do is, we'll take log x minus 2 to the base 2 as t. So it'll be 2 plus t, and here it is 3, and if we interchange the base, it'll be 1 upon t. So we can write t square plus 2t minus 3 equals 0. That is t plus 3 into t minus 1 equals 0. That is value of t is minus 3, or the value of t is 1. Now t is log x minus 2. So from the first one we get x equals 2 plus 1 by 8, which is 17 by 8. And from this second part we'll get log x minus 2 to the base 2 equals 1. That is value of x is 4. Now sum of all the solutions is 7 by 8 plus 4, which is 32 plus 17, and that is 49 by 8, and that's your option C. Now this third question is, we are given that fx plus 1 equals 1 by 2 fx. Now let an equals from 0 to n fx dx. We need to find this limit n tends to infinite an. Now in this equation, if we put x as x plus n minus 1, then we can write fx plus n as 1 by 2 f x plus n minus 1 will be equal to 1 upon 2 square f x plus n minus 2, and using iteration it will eventually come to 1 upon 2 to the power n into fx. Now we need to find this integral an, which is from 0 to n fx dx. Now we need to find this limit n tends to infinite an, which is this summation r varies from 0 to infinite integral from r to r plus 1 fx dx. Now what we'll do is, we'll replace x with t plus r. Then we can write this as this summation r varies from 0 to infinite. Here will be from 0 to 1 ft plus r dt. Now using this relation we can write f t plus r as 1 upon 2 to the power r into ft. So it will be this summation r varies from 0 to infinite 1 upon 2 to the power r, then this integral from 0 to 1 ft dt. Now this is nothing but an infinite GP. Now sum of this GP will be a upon 1 minus r into this integral from 0 to 1. Now ft dt is same as fx dx. So we can write this as 2 times this integral from 0 to 1 fx dx, and that's your option D. Now question number 4 is consider the curves x square plus y square minus 4x minus 6y minus 12 equals 0. Now this is a circle with center at 2, 3 and radius equals 4 plus 9 plus 12, which is 5. So it'll be this circle, and then we have this second equation, which is equation of ellipse, x square upon 100 plus y square upon 250 equals 1. So it'll be this ellipse which contains this circle, and then we have this parabola, which is y square minus 6y minus 6x plus 51 equals 0. Now we'll add 9 and subtract 9, we'll get y minus 3 whole square, and it'll be 6x minus 42, which is 6 into x minus 7. Now vertex of this parabola is at 7, 3. Now center of this circle is at 2, 3 and radius is 5. So this point is 7, 3, which is vertex of parabola. So if we draw this parabola, it will be drawn like this. Now maximum number of disjoint regions in this xy plane will be, now we have 1 region and then 2, 3, 4 and 5. There will be 5 such regions, which is your option number B. Now question number 5 is, a box has 13 distinct pair of socks. If PR denotes the probability of having at least one matching pair among a bunch of R socks drawn at random from the box, if R0 is maximum possible value of R such that PR is less than 1, then the value of PR0 is. Now maximum possible value of R0 so that we do not have any matching socks is 13. Now what we'll do is, in order to find this probability, we'll find the complement of probability when all the 13 socks are distinct. So it'll be 1 minus. Now we need to select 13 distinct socks. So are these 13 pairs? We have to select 13 pairs, and from each pair we can select any sock in 2 ways. So it'll be 2 into 2 into 2, 13 times. So it'll be 2 to the power 13 divided by, now total number of ways is 26 C13. So this probability of R0 will be 1 minus 2 to the power 13 upon 26 C13, and that's your option C. Now question number 6 is, if A, B, C, D are positive real numbers, then the maximum possible value of Cx plus dy over all points on this ellipse. Now any point on the ellipse, we can write it as A cos theta and B sin theta. Now we have to find maximum possible value of this expression. So we'll put x as A cos theta, so it will be AC cos theta and y as B sin theta. So there will be BD sin theta. Now this is A cos theta plus B sin theta, and we know that this is always less than or equal to under root of A square plus B square. So here in this case, it will be A square C square plus B square D square. So maximum possible value of this expression will be under root of A square C square plus B square D square, and that's your option A. Now question number 7 is, we are given this function fx, which is sin x plus alpha x for x belongs to R. If this function is 1, 1, then we need to find range of alpha. Now this function is 1, 1 if it is either strictly increasing or if it is strictly decreasing. Now first we'll find f dash x. F dash x will be cos x plus alpha. Now in the first case, when this function is strictly increasing, f dash x, which is cos x plus alpha, it should be greater than or equal to 0. That is, alpha is greater than or equal to minus cos x. Now value of minus cos x, it lies between minus 1 to plus 1. So in this case, this alpha, it should be greater than or equal to 1. And the second case, when it is strictly decreasing, we'll get f dash x as cos x plus alpha less than equal to 0, alpha is less than equal to minus cos x, which again is from -1 to +1, we'll get alpha should be less than or equal to -1. So answer to this question is either the value of alpha is greater than equal to 1 or less than or equal to -1, and that's your option B. Now question number 8 is telescopic summation. We can write this sum as this summation R varies from 1 to 2021, 1 upon 1 plus 2 plus 3 up to R. Now this is summation R varies from 1 to 2021, and this is R plus 1 by 2. Now we can write this as 2 times this summation R varies from 1 to 2021, and then 1 upon R minus 1 upon R plus 1. Now we can simplify this as 1 upon 1 minus 1 upon 2, 1 upon 2 minus 1 upon 3, and it will continue up to 1 upon 2021 minus 1 upon 2022. Now all these terms, they'll cancel. So this sum will be 2 into 1 minus 1 upon 2022, which is 2021 upon 1011, and that's your option B. Now in question number 9, we are given this region which is mod of x plus 2 times mod of y plus 3 times mod of z less than equal to 6. Now this volume is symmetric about x-axis, y-axis and z-axis. That is, it is symmetric in all the quadrants. So what we'll do is, we'll find volume of the region in one quadrant, that is in first quadrant. And in first quadrant, we'll get this as x plus 2y plus 3z less than or equal to 6. Now this region represents volume of this tetrahedron. We know that volume of tetrahedron, it is given by 1 by 6 ABC, where in this case A is 6, B is 3 and C is 2. So it will be 6 into 3 into 2, so it will be 6. Now volume in one quadrant is 6. So total volume will be 6 into 8, and that will be 48, and that's your option B. Now question number 10 is, let f from R to R be a twice differentiable function such that f double dash x is greater than 0 for all x belongs to R. Now when f double dash x is greater than 0, it simply means that this function is a concave up function. So for any point A and B, graph of this function will lie below this line segment joining A and B. Now for this function, we are given that f0 is 1. So we have f0 1. So this point will be 0, 1, and then at 1 this value is 4. So at 1 this value is 4. So it will be 1, 4. So if we draw the straight line, then since this curve, it is concave up, it will be drawn like this. Now we have to find possible value of f2. So this point is 2 and this is f2. Now what we'll do is, we'll find coordinate of this point on this line. So this point is 2 and suppose this point is k. So we can write k minus 1 upon 2 LB 3. So value of k is 7. So coordinate of this point is 2, 7. Now since it is concave up function, value of f2 must be greater than 7. So f2 cannot take the value 7, and that's your option A. Here the question is, fx is e to the power minus mod x, and we are given this g theta, which is integral from -1 to 1 f x upon theta, which is e to the power minus mod of x upon theta dx. Now this function, it is an even function, so we can write g theta as 2 times, and this integral from 0 to 1 e to the power minus mod x upon mod theta dx. Now when x is greater than 0, mod x is simply x. So it will be 2 times this integral from 0 to 1 e to the power minus x upon mod theta dx. Now if we integrate this function, we can write this as e to the power minus x upon mod theta upon minus 1 upon mod theta, this integral from 0 to 1. So we can write g theta as 2 times mod of theta and then 1 minus e to the power minus x upon mod theta. Now we need to find this limit, which is limit theta tends to 0 g theta upon theta, and there will be this limit theta tends to 0 2 times mod of theta upon theta, and here this value should be 1 minus e to the power minus 1 upon mod theta. Now whether we take this as theta positive or theta negative, it will be e to the power minus infinite, and this will always be 0 for both left hand limit and right hand limit. Whereas this expression, it will be minus 2 in the case of left hand limit, and it will be plus 2 in the case of right hand limit. That means this limit does not exist, and that's your option D. Now here the question is, we have to find number of different ways to color vertices of a square using one or more colors from the set R, B, G, Y such that no two adjacent vertices have the same color. Now for this vertex we have 4 choices, so we can choose any one color and it can be done in 4C1 ways. Now without loss of generality we can say, suppose this color is red. Now if this color is red, then for this next one we have 3 choices. It could be either blue or green or yellow. So for this vertex we have 3 choices, so it will be 3C1. Now suppose this vertex is blue. Now for this third vertex we have 2 cases. Either this vertex is red or this vertex is not red. Now if this vertex is red, then in this case we have 3 choices. It could be any of blue, green or yellow. So in that case it will be 3C1, and if it is not red, then we can choose either green or yellow, so it can be done in 2C1 ways, and if it is green or yellow here, again we'll have 2C1 choices. So total number of ways in which we can paint this square, it will be 4C1 into 3C1 into, now this first case, here it is 1C1 into 3C1 and plus 2C1 into 2C1, which is 4 into 3, and this is 3 plus 4, which is 12 into 7, and that is 84, and that's your option D. Now question number 13 is, we are given this B as P square plus 1, and this A is P cube plus P square plus P plus 11. Now we can write this as P square plus 1 into P plus 1 plus 10. Now D is GCD of A and B, and GCD of A and B will come from factors of 10. Now what are the possible factors of 10? 1, 2, 5 and 10. Now we are given that P is a prime number. Now if the value of P is 2, then in that case this B, it will be 5, and A, it will be 5 into 3 plus 10. So GCD of AB, it will be 5. Now if P is not equal to 2 and P is a prime number, then this P, it must be odd, and if P is odd, then P square plus 1 will be even. Here also this expression will be even, and this 10 is also even. So in that case GCD of A and B, it will be at least 2. So there won't be any case possible in which GCD is 1. So GCD of AB, it cannot be 1 in any of the cases. So the answer to this question is this option B, which is 2, 5 and 10. Now question number 14 is, consider all 2 cross 2 matrices whose entries are distinct and taken from the set 1, 2, 3, 4. So we have this matrix whose elements are A, B, C and D, where A, B, C, D, they are all distinct and they are taken from 1, 2, 3 and 4. Now we have 4 numbers and 4 positions. Now 4 numbers in 4 positions can be arranged in factorial 4 ways, which is 24 ways. So there will be 24 such matrices. Now for every arrangement, say 1, 2, 3, 4, we'll have a matrix in which the 2 rows are interchanged. So there'll be this matrix which is 3, 4 and 1, 2. Now if this matrix is A1, then this matrix will be A1 dash. Now we know that determinant of A1 will be equal to minus determinant of A dash. That is, determinant of A1 plus determinant of A1 dash will be 0. Therefore, for these 24 matrices, there will be 12 matrices which are of the form A1, and then there will be 12 matrices which are of the form A dash 1. So when we'll add all the determinants, sum of all the determinants will be simply 0, and that's your option D. Now question number 15 is, let A, B, C and D be 4 non-negative real numbers where A plus B plus C plus D it is equal to 1, and number of distinct ways in which we can choose these numbers such that A square plus B square plus C square plus D square equals maximum of A, B, C, D is. Now we'll consider this first case when 3 of them they are 0. B equals C equals D equals 0. Then in that case, value of A is simply 1, and we have one solution which is 1, 0, 0, 0, and then it could be either B or C or D. So there will be 4 such cases. Now we'll take the second case when A and B they are unequal to 0 and C and D they are both 0. So if C and D they are both 0, we'll get this condition that A plus B equals 1 and A square plus B square equals now maximum of A and B. Now without loss of generality, we'll assume that maximum is suppose A. So if it is A, then if we put B as 1 minus A, we can write A square plus 1 minus A whole square equals A. So it will be 2A square minus 3A plus 1 equals 0, and there will be 2A minus 1 into A minus 1 equals 0. So value of A is either 1 by 2 or the value of A is 1. Now A equals 1, it will give us B equals 0. So we'll discard this. So here we have this case where A is 1 by 2, B is 1 by 2, and then both C and D they are equal. Now there will be factorial 4 upon factorial 2 factorial 2. There is 6 such cases. So number of such cases will be simply 6. Now we consider this third case when D is 0 and A, B and C they are not equal to 0. Then in that case we'll get A plus B plus C equals 1 and A square plus B square plus C square equals to A. Now if we solve this equation, the only possible real root will be when each of A, B, C they are 1 by 3. So it will be 1 by 3, 1 by 3, 1 by 3, comma 0. Now we can rearrange it in 4 ways. So there will be 4 such cases, and then finally we'll have this fourth case where none of A, B, C, D is unequal to 0, and in that case the only real solution possible is 1 by 4, 1 by 4, 1 by 4 and 1 by 4, and there will be only one such case. So total number of cases will be 10 plus 4 plus 1, 15. So answer to this question is 15, and that's your option D. Now question number 16, we are given this polynomial and it says it has at least one real root. Now suppose this is some function fx which is x to the power 4 plus 4x plus c. Now we find f dash x will be 4x cube plus 4, and if we put it equals to 0, the only critical point is x equals minus 1. Now f double dash x will be 12x square plus 4, which is greater than 0. That means x equal to minus 1 is point of minima. So this function will be concave up and will have a minima at minus 1. And if we find value at minus 1, value at minus 1 will be 1 minus 4 plus c, and there will be c minus 3. Now this function, it will be drawn concave up with minima at minus 1. Now this function, it will have at least one real root when either it touches x-axis or it intersects x-axis, and it is possible when this minimum value f minus 1 is less than or equal to 0. So from here we'll get this condition that c minus 3 is less than equal to 0, that is value of c is less than or equal to 3, and that's your option D. Now question number 17 is we need to find number of all integral solutions of this equation, which is x square plus x plus y square minus y equals 2, 0, 2, 1. Now we'll complete perfect square. We'll add 1 by 4 and here will be 1 by 2. So it will be x plus 1 by 2 square plus y minus 1 by 2 square, and here it will be 4042 plus 1, 4043 by 2. Now we can also write this as 2x plus 1 whole square plus 2y minus 1 whole square, and it will be 8086. Now if we look at square of any odd number, we can write this as 4n square plus 4n plus 1. It will be 4n, n plus 1 plus 1. Now out of n plus 1, one of them is even. So 2n plus 1 whole square is 1 modulo 8. So if we take LHS modulo 8, it will be congruent to 2 modulo 8, whereas on the right hand side 8086 when divided by 8 leaves the remainder 6, so it will be 6 modulo 8. That is LHS is not equal to RHS. So number of all integral solution in this case will be simply 0, and that's your option D. Now question number 18 is number of different values of f for which this equation has two identical real roots. That means two of the roots are alpha and alpha, and if alpha is a double root, then f alpha is 0 and also f dash alpha is 0. Now we'll take fx as x cube minus x plus a, and f dash x will be 3x square minus 1, and if we put it equals to 0, we'll get x as plus or minus 1 by root 3. Now this double root, it could be either x equals 1 by root 3 or x equals minus 1 by root 3. Now if we put x as 1 by root 3, we'll get this as 1 upon 3 root 3 minus 1 by root 3 plus a will be equal to 0. So here the value of a will be 2 upon 3 root 3, and if we put x as minus 1 by root 3, we'll get this as minus 2 upon 3 root 3. So there'll be two such values of alpha possible. So number of different values of a is simply 2, and that's your option C. Now in question number 19, we are given that fx is a twice differentiable function such that fa equals 0 equals fb, and then we are given this condition. Now we can write this as x square f double dash x plus 2x into f dash x plus 2 x into f dash x plus fx greater than 0. Now this is d x square f dash x, and this is d 2x fx, and it will be greater than 0. We can also write this as x square f dash x plus 2x fx, it is greater than 0. Now we can also write this as d square x square fx is greater than 0. That means x square fx function, which is say hx, it is concave up function. Now if we find HA will be a square into fa, which is 0, and HB, which is b square into fb, will also be 0. So this function hx will be drawn like this, where x square fx, when x lies between a and b, will be less than 0. So x square fx, it will be less than 0, which simply means fx is less than 0 for all x belongs to a comma b, and that's your option A. Now question number 20 is, we are given a as 1 by z where mod of z equals 2. Now if mod of z is 2, then z is 2 into e to the power iota theta. Now we are given some w which is 1 by z, and it will be 1 upon 2 e to the power iota theta, which is 1 by 2 into e to the power minus iota theta. Now mod of w is 1 by 2. That means this w, it lies on a circle. So this a, it will lie on a circle. Now for b, we are given that mod of z minus 1 equals 2. That is z minus 1 equals 2 into e to the power iota alpha, or z is 1 plus 2 into e to the power iota alpha. Now again we are given w is 1 upon z, which is 1 upon 1 plus 2 e to the power iota alpha. Now we cross multiply, we can write w plus 2 into w e to the power I alpha equals 1, or e to the power I alpha will be 1 minus w upon 2w. Now we take its mod, then we can write mod of 1 minus w upon 2w equals 1. That is mod of w minus 1 upon w, it is equal to 2. Now when mod of z minus z1 upon z2 minus z1 is k, and k is unequal to 1, then z lies on a circle. So in this case, this b, it will also lie on a circle. So both a and b, they are circles, and that's your option C. Now question number 21 is, for a positive integer n, the equation x square equals n plus y square does not have a solution if and only if. Now we can write x square minus y square equals n. Now if we take this n, an even number which is not divisible by 4, we can write this n as sum 4k plus 2. Now we can write x plus y into x minus y will be 2 into 2k plus 1. Now this 2, it can go to any one of x plus y or x minus y. Now in this case, one of them should be even and the other one, it should be odd. But we know that for x and y, x plus y and x minus y, they have the same parity. They can either be both even or both odd. So here we have a contradiction. So it is not possible to have n as some even number which is not divisible by 4, and that's your option D. Now in question number 22, it says f be any twice differentiable function such that its second derivative is continuous, and f dash x, it is unequal to 0 for all x unequal to 0. Now if limit x tends to 0, fx upon x square equals pi, then which of the following is correct? And this we have also proved in one of the previous papers. I think that was 2010 or 2011 paper, where we have proved that value of f0 will be 0 and f dash 0 will also be 0. Now if it is 0 upon 0 form, then we can write f double dash 0 upon 2 will be equal to pi. That is f double dash 0 will be simply 2 pi. Now since f dash 0 is 0, that means x equal to 0 is a critical point, and f dash 0, it is greater than 0. That means this x equal to 0 is a point of local minima. So at 0, this function will be concave up, and it will also have a point of local minima at x equal to 0. And since fx is unequal to 0, that means at no other point it will have a critical point. So this is the only critical point possible in this case. So at 0, we have a double root that is concave up. Now after x is greater than 0, this function will increase because there is no other critical point. And on the left hand side also, this function will be a decreasing function. This function cannot increase when x is less than 0, because it will contradict our given condition where f dash x is 0 and f double dash x is positive. So this f0, it is the least possible value of this function. That means fx is greater than f0 for all x unequal to 0, and that's your option A. Now question number 23 is, we need to find this limit n tends to infinite fractional part of 3 plus 2 root 2 to the power n. Now what we'll do is, we'll say, suppose its integral part is r and fractional part is f, we can write this as 3 plus 2 root 2 to the power n. Now this is nc0 3 to the power n plus nc1 3 to the power n minus 1 2 root 2 and so on, and then we'll consider this f, which is 3 minus 2 root 2 to the power n. It lies between 0 and 1. This capital F, it lies between 0 and 1, and here also any fractional part, it lies between 0 and 1. Now if we add them, we can write r plus f will be 2 times 3 to the power n plus nc2 3 to the power n minus 2 into 2 root 2 square. Now this right hand side, it is integer. This r, it is also an integer. That means this f plus f, it must also be an integer. Now if we add capital F plus small f, it lies between 0 and 2, and the only integral value possible in this case is 1. So we can write this small f as 1 minus capital F, or fractional part of 3 plus 2 root 2 to the power n will be 1 minus 3 minus 2 root 2 to the power n. Now we'll take this limit n tends to infinite. Limit n tends to infinite. And this is 1, and this value, it lies between 0 and 1. So a to the power infinite in this case will be simply 0. So answer to this limit is 1, and that's your option B. Now in 24 we are given this function f and x, which is e to the power n times, and it will be e to the power f naught x. Now if we differentiate this function, then it will be e to the power f naught x into, now we'll come to this, it will be e to the power f naught x, and this way it will continue, and finally it will be e to the power f naught x into f naught dash x equals 0. Now exponential function, it can never be 0. The only condition that we'll get here is derivative of f naught x, it must be 0. Now f naught x is this integral. So we have to find f naught dash x will be px when x is greater than or equal to 0. Now we look at this px, we can write this as x, and here will be x square minus 3x plus 2, which is x minus 1, x minus 2, and if we put it equals to 0, we get x as 0, 1 and 2. So if we put it equals to 0, we'll get 3 roots, which are 0, 1 and 2. So number of roots in this interval is 3, and that's your option B. Now question number 25 is, we have to find number of solution to this equation. Now we are given sine square x. Now we can write this as sin x into cos x plus 2 sin x cos x plus 2 cos square x equals 0. So it will be sin x plus cos x and sin x plus 2 cos x equals 0. That is, either we'll get 10x as minus 1, or we'll get 10x as minus 2. Now between 0 and 2 pi, we have this graph. Now if we draw line at 10 equals minus 1 and 10 equals minus 2, it will intersect this graph at 4 points. So number of solutions is simply 4, and that's your option D. Now question number 26 is, we are given fx plus y equals fx into fy. Now this is standard condition, and we solve it, we get fx as a to the power x. Now we are given that f dash 1 is 2. So if we differentiate this function, f dash x will be a to the power x log a. F dash 1 will be a log a, and which is 2. Now we need to find the value of f1 and log f1. Now f1 is simply a. So it is a into log a, and we know that a into log a is 2, which is option B. Now 27 is this expression, which is 10 1 plus 2 10 2 plus 2 square 10 2 square up to 2 to the power 10 10 2 to the power 10 equals what? Now what we'll do is we'll add cot 1 and we'll subtract cot 1. Now if we simplify this, we can write this as 1 and 1 minus 10 square 1 upon 10 1. We'll multiply with 2 and divide by 2. So it'll be minus 2 cot 2 plus 2 10 2 plus 2 square 10 2 square up to 2 to the power 10 10 2 to the power 10 cot 1. Now again if we simplify this, we'll get this as minus 2 square cot 2 square, and next one will be minus 2 cube cot 2 cube, and finally when we'll solve this, we'll get this as minus 2 to the power 11 cot 2 to the power 11. So its final answer will be cot 1 minus 2 to the power 11 cot 2 to the power 11, and that's your option D. Now 28 is we need to find maximum and minimum value of this expression. Now this is a cube plus b cube. So we can write this as sine square x whole cube plus cos square x whole cube, which is a plus b whole cube minus 3ab a plus b. So it'll be simply 1 minus 3 sine square x into cos square x. Now we'll multiply by 4 and divide by 4. So we can write y equals 1 minus 3 by 4 into sine 2x whole square. Now minimum value of sine 2x is 0 and its maximum value is 1. So y minimum value will be when sine is 1. So it will be 1 minus 3 by 4, and that is 1 by 4. And its maximum value is when the value of sine is 0. So it will be 1. And a minus b will be 1 minus 1 by 4, and it is 3 by 4. And that's your option C. Now question number 29 is two real numbers x and y satisfy x plus 5 square plus y minus 10 square equals 14 square, which is a circle with center at minus 5 comma 10 and radius equals 14. Now we have to find minimum possible value of x square plus 2x plus y square minus 4y. Now we'll complete this perfect square. We'll add 5 and subtract 5. We'll get x plus 1 square plus y minus 2 square and then minus 5. Now this is distance between x, y and minus 1 comma 2. So we have a point which is minus 1 comma 2. We have to find shortest distance of this point from the points on this circle. This is the distance that we need. Now this is suppose D. Now we can write D as under root of minus 5 plus 1. That is 4 square, and here it is 8 square, which is 4 root 5. So suppose this is A, B and C. So in this case, value of BC will be 14 minus 4 root 5. Now what you are given here is BC square minus 5. So it will be 14 minus 4 root 5 whole square and then minus 5. Now which is 271 minus 112 root 5, and that's your option A. Now question number 30 is we have to find its continuity and differentiability and continuity of its derivative. Now f0 will be 1 minus cos 0 1, so it will be 0 into oscillating value minus 1 to 1, which is 0. So this fx will be continuous at x equals 0. Now if you find f dash 0, it will be limit h tends to 0 1 minus cos h upon h into sine 1 by h. We multiply by h and divide by h. So it will be 0 into 1 by 2 into oscillating value minus 1 to 1, which is 0. So this function is both continuous and differentiable in x belongs to R. Now we have to find continuity of its derivative. Now if we find f dash x, it will be 1 minus cos x into cos 1 by x into minus 1 upon x square plus sin x into sin 1 by x. Now if we find f dash 0 positive, it will be, now this is 1 minus cos x upon x square, which is minus 1 by 2, and this is cos infinite, which is oscillating value from minus 1 to plus 1, and this right hand side will be 0 into oscillating value minus 1 to plus 1. So we are getting this value as oscillating value between minus 1 by 2 and plus 1 by 2. That means this function is differentiable, but its derivative is discontinuous, and that's your option C. Now from tomorrow onwards, again I'm traveling, so I don't know when I'll be able to solve the UGB paper. I'll try to do it as early as possible.